Okay, today we're going to learn about mole conversions and the mole specifically. Okay, now the mole is a chemical mass unit used in chemistry to represent a specific amount. That number that we're talking about is referring to Avogadro's number. Okay, Avogadro's number is 6.022 times 10 to the 23rd particles, atoms. It can be anything. It could be grains of sand. It could be stars of the galaxy. It doesn't matter because Avogadro's number, or the mole, is a constant. This can be whatever you want it to be. If you have 1 mole of something, then you have this many somethings. Okay, so just understand that a mole is a constant. Now, what does that have to do with chemistry? When we're talking about chemistry, right, let's take a look at an example like magnesium. This is what it looks like on the periodic table of elements. You have an atomic number, which represents the number of protons and electrons. You have the chemical symbol, right, which in this case is magnesium. And at the very, very bottom, you have the atomic mass. Now, the atomic mass is what we're going to be focusing on because this is giving you the mass of 1 mole of atoms of magnesium, right? It's 1 mole of atoms of magnesium. So what this is basically telling you that if I was to take, okay, individual atoms and I was to collect this many atoms of magnesium, which is a huge, huge number, okay? If I was to take this many atoms of magnesium, all those atoms put together would have a mass of 24.03 grams, right? So when we're looking at something like 24.03, the atomic mass, what we're really saying it's 24, well, what we're really saying is that it's 24.03 grams of magnesium per 1 mole of those atoms, right? That's really what we're saying. So the new unit that we're going to be talking about in atomic mass is going to be grams per mole. All right, now let's go ahead and clean this up for a second. Let's take a look. Okay, so here we go. Clean slate. Let's go ahead and work an example. Okay, let's take a real quick, simple example just to kind of get our feet wet, okay? So I'm going to do a quick little example, but instead of doing moles and atoms, or grams, what we're going to do is we're going to do time, okay? Just to kind of get our feet wet. Now, let's say you watch a movie, and that movie is 2.5 hours long, right? Now, I want to know how many minutes that is, okay? In order to figure that out, I need to know my conversion factor. Now, what's a conversion factor? Okay? A conversion factor is when you take 1 unit and you set it equal to another. For example, I know that 1 hour is equal to 60 minutes, right? So here I have the unit of hours equal to the unit of minutes, okay? This number is equal to that number. So let's set up our conversion real quick, okay? The typical format for dimensional analysis is very simple. You take your given, okay, you put it over 1, and then you multiply by whatever your conversion factor is. Okay, I'm going to abbreviate this. Okay, you set it up to your conversion factor. Okay, now in order to do this correctly every single time, okay, all you have to do is figure out which part of the conversion factor goes on the bottom. Okay, so let's set it up. What's my given? In this one, my given is 2.5 hours. Right? I'm going to put that over 1. Now, I'm going to multiply this by my conversion factor. Now, let's take a look at it. Here, I have 2 values, and here, I have 2 spaces, right? All you have to do is figure out which one of these goes right here. I'll give you a hint. If you have hours here, you want to put hours here, so they cancel out. So if 1 hour then goes on bottom, what has to go on top? Well, in this case, the 60 minutes, right? What happens to the hours? Well, the hours cancel. And if the hours cancel, what are you left with? You're left with minutes. So whatever answer you get, you're going to get in minutes. At this point, all you have to do is multiply 2.5 times 60, 1 times 1, okay? So 2.5 times 60 is gives me, let's see, 100. So 150 minutes. You've now just converted from hours to minutes. Okay, so that was an easy one. All right, now we're going to try one in chemistry. Okay, we're going to do using moles. Now the cool thing about all this, right, is it doesn't matter what the units are, right? They can be hours, they can be minutes, they can be moles, they can be atoms. It doesn't matter because the process never changes. It's still exactly the same. So I'm going to go ahead and clean this up, and then we're going to try another example. Okay, chemistry time. Here's my example. Okay, I have 3.2 moles of calcium. I want to know how many atoms that is. Okay, first thing you want to do is you got to figure out what is my conversion factor, right? What is it? Now, the way I remember it, all right, is if I see an A for atoms, first thing I think Avogadro's number, right? So if I'm already thinking Avogadro's number, then I know that 1 mole is equal to 6.022 times 10 to the 23rd atoms. Right? That's my conversion factor right there. Right. Now, we have our conversion factor, so let's set up our problem. First things first, what's our given? Right? Our given in this case is 3.2 moles of calcium. Put it over 1. I'm going to multiply that by my conversion factor. So remember what I said earlier. In order to set this up correctly, all you have to know is which one of these goes on bottom, right? Now my conversion factor says that 1 mole of calcium is equal to 6.022 times 10 to the 23rd. So if I have moles of calcium here, then I want to put moles of calcium here. So for me, 1 mole of calcium goes at the bottom, and 6.022 times 10 to the 23rd atoms of calcium goes at the top. See that? Okay. All right. Now, what happens to my moles? My moles cancel. If my moles cancel, then my answer is going to end up in atoms. Whatever my answer is going to be atoms of calcium because that's the only unit that's left. Right? So all I have to do now is I have to multiply this times this times this, right? Okay, so let's take a look. My answer becomes 1.927 times 10 to the 24th atoms of calcium. Now, because my initial number was in 2 digits, significant digits, right? I'm going to go ahead and round this so it goes to just 1 decimal place, right? So let's rewrite it. Okay, if I round this, it's going to be 1.9 times 10 to the 24th atoms. Calcium. Okay, and this is my final answer. Easy, right? Okay, I cleaned things up a little bit. Let's go ahead and try another example. All right, this time what we're going to do is I'm going to go from atoms of magnesium to moles of magnesium. The setup's still exactly the same. Okay, nothing changes. You still need a conversion factor, right? You still need a conversion factor, which I'm going to abbreviate CF. Okay, and you still need to cancel units. Now, I said before, if I see the A for atoms, I'm thinking Avogadro's number, so my conversion factor is going to be the same as before. 1 mole of magnesium, because we're working with magnesium this time, is still equal to 6.22 times 10 to the 23rd atoms of magnesium. Right? Okay, so I'm going to write that in here. All right, so there's my conversion factor. Okay, let's set up our problem. Okay, let's see. Here I have my given. In this case, my given is 4.23, right, times 10 to the 20 atoms. Magnesium. Sorry, it's a little messy. I'm going to put that over 1. All right, and then I'm going to go ahead and multiply that by my conversion factor. So, same rules apply as before, right? I have two values, and I have two spaces. So which one's going to go on bottom? Am I going to put the moles on bottom, or am I going to put the atoms on bottom? Well, hint, hint, if I have atoms here, then atoms have to go there. So let's go ahead and write that one in. All right, 6.022 times 10 to the 23rd atoms. And if atoms are on bottom, moles have to go on top. There it is, mole of magnesium, right? Okay, so if I put those in there, right, what's going to happen to atoms of magnesium? Well, the atoms are going to cancel out, right? If atoms cancel out, then what's the only unit left? Well, the only unit left here is going to be moles of magnesium, and that's exactly where we want to be, all right? Now, what happens here? Well, all you have to do now is multiply straight across the top, straight across the bottom, and you get your final result. In this case, 4.23 times 10 to the 20th times 1, guess what? It gives me 4.23 times 10 to the 20th, right? Nothing changes, all right? 1 times 6.022 times 10 to the 23rd, big surprise, is going to be the exact same thing. So I'm going to write 6.22 times 10 to the 23rd. Now, these are my two final numbers, so what happens to these two guys here, right? These two guys, well, now you divide them. Once I divide them, I get my final answer, and in this case, the final answer is going to be 0.70242 moles of magnesium, right? You can put a 0 in the front if you wish. Now, I have to take a look, because I'm not done, right? I have to take a look of which one of these has the smallest amount of significant figures. In this case here, I have only 2 decimal places. So what I'm going to do is I'm going to take these numbers and I'm going to round them down to the second decimal place. Once I do that, then my final answer becomes 0.70 moles of magnesium. Okay, and that right there is my final answer. So, recap. What did we do? Okay, well, we figured out that we're working with atoms this time, and now we want to go to moles. We know that because we see atoms, we're going to use Avogadro's number, and all we did was set it up in the exact same way. You take your given, right? You multiply it by your conversion factor, and all I had to do was figure out which one of these goes on bottom. In this case, because I have atoms here, I put the atoms at the bottom and the moles at the top. Once I do that, multiply straight across, take these two numbers, divide them, ended up with this number, put it to the correct significant digits, and here is my final answer right there. It's pretty simple. Now, what I want you to do now is I want you to take a second, pause the video, and go ahead and try and work through some of your guided practice problems. Okay, the first two problems that you're going to see on your handout are going to be related to going from moles to atoms, atoms to moles. Okay, even though we're working with magnesium, on your handout you're going to see that you're working with things like ammonium. Okay, it's no different. 6.022 is still the same whether you're doing magnesium or magnesium oxide, if it's a compound or an element. So go ahead and pause it now and take a few minutes to work on those. All right, welcome back, everybody. By this time, you should have worked with a few of the problems on your guided practice, and I wanted you guys to take this opportunity to take a look at something. On your guided practice, you would have seen different things. You might have seen atoms, you might have seen particles, you might have seen molecules, or anything that says representative particles. Okay, I did this on purpose. I wanted you guys to think about this before you came over and asked for help. When you see any one of these units, atoms, particles, molecules, representative particles, it doesn't matter, okay? All these units, right, that you see here are going to be using Avogadro's number, okay? So whenever you're looking at something that says how many atoms, how many particles, how many molecules of this particular compound / element you're working with, that's got to be the red flag to say, hey, I got to use 6.022 times 10 to the 23rd atoms, or particles, or molecules. It doesn't matter. It's always going to be that conversion factor, okay? All right, now what we're going to do next is we're going to go ahead and we're going to show you, or I'm going to show you how to convert from moles to grams, okay? And to go from moles to grams, right, you have to use, atomic mass. All right, so I'm going to go ahead and clean this up a little bit, and then we're going to do a couple of practice problems. Okay, all cleaned up. Let's go ahead and get started. What we're going to do right now is we're going to go from moles to grams. Okay, that's the conversion we're going to do right now. Now, first thing you got to do, first step, is you got to find the conversion factor, right? You can't do anything until you have a good conversion factor. Now, in this case, you got to ask yourself the question, are we going to be using, well, I misspelled that. Are we going to be using Avogadro's number? The answer to your question is no. We're not going to be using Avogadro's number because now we're going to grams. So I'm going to show you something here. When I see grams, the first thing I look at that is that G. When I see that G, this is what comes to mind. G for go to the periodic table. Okay. I don't know why that's so messy. Or G for get atomic mass. Okay. So for this type of problem, in order for us to work it out, we're going to need to find atomic mass. So let's take a look at sodium. On the periodic table, I know that the mass of sodium, which is Na, is equal to 22.9. Right? So that's 22.9 grams per mole. Another way to say that is that 1 mole of sodium has a mass of 22.9 grams of sodium. Okay, so there it is. Okay, there's my conversion factor. So let's set up our problem. All right, same way as always, you take your given, 6.31, okay, moles of sodium, put it over 1. I'm going to multiply that by the conversion factor. Now, same as before, I have two values and I have two spaces. So which one goes on bottom? Just like before, if I have moles here, moles have to go here. So let's go ahead and write that in. In this case, 1 mole of sodium, it's going to have a mass of 22.9 grams of sodium. What happens to my moles? Well, in this case, my moles cancel. Right? If my moles cancel, what's the only unit that's left? Well, the only unit that's left is going to be grams sodium. So whatever answer I get is going to be in grams. So what do you do now? Okay, well, you multiply straight across the top, you multiply straight across the bottom, and that should give you the answer. And in this case, the answer is 144.49 grams sodium. Right? There you go. Now remember, you're not done. You got to look at your significant figures. This one only has 1 decimal place right here. So I'm going to round this one up to 1 decimal place. And my new and improved answer is going to be 144.5 grams of sodium. And this is the answer that you box in. Pretty simple. Okay, last problem. Okay, this time we're still doing grams to moles, moles to grams. Okay, this time we're going to go from grams to moles. All right, so here's what I'm working. I have 321.4 grams of oxygen, and I want to know how many moles that is. Okay, process is still the same. In this case, I'm going to write down my conversion factor. So I know that 1 mole of oxygen has a mass of 15.99 grams of oxygen. Right? Of oxygen. Sorry. Okay, so there's my conversion factor. Let's go ahead and set up our problem. Okay, first things first, as always, we take our given and we put it over 1. In this case, we have a given of 321.4 grams of oxygen. Okay, put it over 1. Then I'm going to multiply that by my conversion factor. You ask yourself the same question. Which one of these goes at the bottom? Well, since I have grams oxygen here, guess what I'm going to put at the bottom? Grams oxygen. All right, so let's write it in. 15.99 grams of oxygen. All right, and then at the top, what are we going to write? 1 mole of oxygen. So basically what we're saying is that 1 mole of oxygen has a mass of 15.99 grams. Okay, what happens next? Well, in this case, the grams cancel, as always. And if grams cancel, the only unit left is moles oxygen. Okay, what does that mean? That means that whatever answer I get is going to be in moles. Multiply straight across the top, multiply straight across the bottom. In this case, this symbol means therefore. Therefore, 321.4 times 1, guess what? Is 321.4. Okay, 1 times 15.99 is 15.99. All right, and then these two numbers get divided. Once I divide them, I end up with 20.10 moles oxygen. If I want to keep it to the same decimal place, then it becomes 20.1 moles oxygen. And this is the one you box in. Got to remember, you got to keep them to the correct significant figures, and this is your final answer. Okay, the setup is exactly the same. We're still canceling units. Okay, we're still eliminating, we're still looking for the final conversion. Okay, given over 1 times the conversion factor. That's never going to change. All right, so that's it. That's it. I'm done. Now, the only thing I want to give you guys a heads up is all the examples that we've been doing have been with elements. Okay, if you're working with compounds, for example, let's say, let me go ahead and clean this up a little bit. Let's say you were working with moles of H2O, right? H2O. Well, obviously you can't use atomic mass, right? Because this is a compound. So instead of using atomic mass, right, if you have H2O, you would be using molar mass, right? You would be using molar mass. So for this one, you would have to find the molar mass to use in the conversion. So then 1 mole of H2O would be equal to the molar mass of H2O, which is, if you remember, hydrogen, oxygen. This is 1 times 2, sorry. And this is 1 times 16. So that's 2, 16. That gives me 18. So then my molar mass would be 18 grams, right? So nothing different, right? Nothing different. You would just be using molar mass of the compound instead of atomic mass of the element. All right, let me go ahead and clean this up for one more little thing, and then that's it. Where's my little... All right, gone. All right, last thing is we want to take a look at the mole map, right? The mole map is very simple. Basically, I want you to treat the mole, the atoms, the grams, as if it were time, right? If it were time, your atoms, your atoms would be like your seconds. Your moles would be like your minutes, and your grams would be like your hours, right? If I was to ask you how many seconds are in 1 hour, you're probably not going to know that. But you do know how many seconds are in a minute, and you do know how many minutes are in an hour, right? So when you're going from atoms to moles, that's pretty simple. When you're going from moles to atoms, that's pretty simple. When you're going from moles to grams, that's pretty simple. When you're going from grams to moles, that's pretty simple. But if you have to go from atoms to grams, you have to stop in moles first, right? You're going to go from atoms to moles from moles to grams. And this little mole map is available on that sheet that I gave you guys on Monday. So take a look at that, okay? Think of the atoms, the moles, and the grams like time, seconds, minutes, hours. If you want to get to hours, you got to go through minutes first. All right? Okay, I know it's a really long video, but you're supposed to be watching this over a couple of days, so don't worry about it. Pause it, rewind it, watch it again, watch it at home because it's on YouTube. And if you guys have any questions, let us know.